Welcome to The Explainer. Today, we are cracking the code on further transformations for Cambridge 0580 mathematics. We're stepping away from the traditional, repetitive grinding and looking for the back door into every question. It's all about working smarter, not harder. Let's jump right in.
Okay, so be honest. Have you ever looked at a transformation question, stared at that coordinate grid, and felt like you were just kind of guessing where a shape should go? Don't worry, you absolutely aren't alone. Most students think that simply drawing the new shape is the whole battle, but actually, it's often only half the points. So how do you perfectly describe a transformation to secure full marks? Well, today, we're treating these math problems differently. Not as an abstract chore or random drawing exercise, but as a highly predictable visual logic puzzle. There's a system here. We are going to find the mathematical backdoor to acing these questions every single time.
Think of every transformation as a unique lock that requires a very specific mathematical key. For example, if you're dealing with an enlargement, you literally cannot just write down "it got bigger." The examiner will give you 0 for that. You must provide the exact scale factor, and you have to pinpoint the precise coordinate of the center of enlargement. On the flip side, for a reflection, writing "it flipped over" simply won't cut it either. You need the full algebraic equation of the mirror line. It's all about giving the examiner exactly what they're looking for. Let's break these down one by one.
Part 1. Decoding enlargements. Now, when you're given an object and its enlarged image on a grid, finding the scale factor and marking that elusive center of enlargement might look totally intimidating. But listen, there is a foolproof mechanical process. No guessing required. Pick a corresponding corner on both shapes. Let's call them point A on your original object and point A prime on the new enlarged image. Step 1. Just draw a straight line connecting them. Step 2, take your ruler and extend that line way out across the grid. Now do the exact same thing for another set of corners, like point B and B prime. Step 3, look at where those extended lines cross each other. That intersection point, boom. That is definitively your center of enlargement. It's exactly like tracing light rays backward into a film projector. Before we continue and get into the really tricky exam traps, subscribe to our YouTube channel Ace the Exams at acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, so once you have that center point, calculating the scale factor is usually pretty straightforward, right? You just compare the lengths of the sides. But examiners love to throw in a massive twist to see who's really paying attention. So, what actually happens when the scale factor is negative?
Take a look at this, negative 2.5. A negative scale factor literally means the enlarged image is projected to the completely opposite side of the center. It's like you've entered a mirror universe. Think about a normal, positive scale factor of 2. You start at the center, walk to the object, and keep going in that exact same direction twice as far. Simple. But with a negative 2.5, you walk from the center to the object, and then you slam on the brakes and reverse your direction completely. You walk exactly 2.5 times that distance backward, straight through the center point. The resulting image isn't just 2.5 times larger, it's completely inverted. It's upside down and back to front. So the ultimate rule of thumb, if you see a negative sign in front of that scale factor, immediately tell your brain, go through the center and out the other side. It is a classic exam trap, but once you visualize it as a projection passing through a central lens, kind of like how a camera lens flips an image, it makes perfect geometric sense. You just flip your perspective across that center point and draw what you see. And hey, stop scrolling for just a second. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Part 2, through the looking glass.
Okay, let's pivot our strategy from size and position to pure symmetry. We're talking reflections. For reflections, drawing the flipped shape on the grid is, again, only step 1. You must define the mirror line perfectly using algebra. This mirror line is the exact halfway point, the essential axis of symmetry between your original object and its new image. Without stating its physical position and its algebraic equation, your answer is fundamentally incomplete, and you'll drop easy marks. Let's start with the foundations. The classic y equals 0 is just the mathematical name for the x-axis. Why? Because everywhere on that flat horizontal line, the y-coordinate is literally 0. It doesn't go up, it doesn't go down. Similarly, x equals 0 is the y-axis. Students mix these up all the time because it feels a bit backward, so be careful there. You'll also face lines like x equals 2 or x equals -1. These are your fundamental straight up and down vertical lines. They are honestly the easiest to spot because you can just count the grid squares straight across from your object to find the middle. But how do we decode the puzzle when the reflection isn't a nice, neat vertical or horizontal line? What happens when things get really tricky and the shapes look like they've been reflected at a sharp angle across the grid?
When a reflected shape is offset like this, you simply connect the corresponding points of the object in the image, just like we did with enlargements. But this time, you want to find the exact middle of those connecting lines. Marking those midpoints reveals a diagonal mirror line. Let's look at the derived equation y equals x plus 1. What does that actually mean in plain English? It simply means that for every single point on that mirror line, its y-coordinate is exactly 1 greater than its x-coordinate. So if x is 2, y is 3. If x is 4, y is 5. Connect those dots, and it cuts a perfect 45-degree diagonal path right across your coordinate grid, just offset upwards by 1 single unit. To truly master this section and hack the exam, you need to be able to map and recognize these advanced diagonal equations on a coordinate grid without a second thought. You have the standard y equals x, which cuts diagonally right through the 0, 0 origin. You have y equals -x, which cuts diagonally in the complete opposite direction. And then you have those shifted diagonals like y equals x plus 2 or y equals -x minus 1. Here is the ultimate trick when you face these. Just pick a couple of random x values, calculate what the y values would be, plot those dots, and literally draw your mirror line before you even attempt to reflect the shape. Once that line is physically drawn on your paper, the visual reflection becomes dramatically easier. And there you have it. We've navigated the tricky traps of negative scale factors, and we've decoded the algebra behind diagonal mirrors. You now hold the exact mathematical keys to unlock these spaces. The next time you sit down with a past paper and face a transformation grid, remember our strategy. You aren't just sketching shapes, you are commanding the rules of the grid. Students who implement these exact strategies see an average improvement of 2 whole grade boundaries, but only if they practice consistently. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Also drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this explainer with a study partner. Thanks for joining me and keep decoding.